Hi all. Welcome to the module covering basic machine learning techniques. This module consists of a number of units. In the first, we'll develop some intuitions about how classification problems work, what are classification problems, and how we might just kind of intuitively solve these problems. Next, we'll look at a very simple machine learning technique called k-nearest neighbors, or KNN. Once we understand how the algorithm works, we'll turn to working on it in a Python code. And in order to do this, in fact, in order to do any machine learning work, we need some basic skills with a handful of Python libraries such as NumPy, Pandas, and scikit-learn. Before doing any of this, let's talk a bit about coding. In this course, we're going to be doing an awful lot of coding. And by we're going to be doing an awful lot of coding, I basically mean you. So you see, if you're trying to learn to play guitar and you're learning by watching YouTube videos, you're not going to learn it by watching YouTube video after YouTube video about playing guitar. So the key element is deliberative practice. It's not how many hours you spend watching YouTube videos on how to play the guitar. And the same thing applies to everything else in life, including coding. So you're not going to learn how to code by watching YouTube videos. Those are instructive, but you're going to learn how to code by actually practicing coding. So in this series of videos, I'll help you get started and give you some guidance, and then let you finish the exercises on your own. As this is a very old CD cover from one of my first C compilers I bought, just called Blood, Sweat, and Code, and that pretty much mirrors what we'll be doing. It's not quite as harmful as that suggests, but nonetheless, it'll be some work involved. It's work involved in doing this. So our work, we're going to be using what's called Colab, Google Colab, and it's a free browser-based service that allows us to experiment with machine learning without the need to install anything on our laptops, without the need for any fancy hardware like graphics cards that enable us to do deep learning. So it's a very useful tool. We'll be able to do it free online. Colab uses what's called Jupyter Notebooks. Now, Jupyter itself is a nonprofit that develops open source software, Jupyter Notebooks among them, and this Jupyter Notebooks allows us to experiment kind of interactively with machine learning techniques. So it allows us in one notebook to have blocks of executable code that we write that the computer will run and do machine learning. And that notebook also can contain blocks of text, some documentation, formatted documentation that'll help us when we want to try to understand what we're doing or just keep notes of what we're doing. So we're going to be using Jupyter Notebooks. I mentioned in an earlier video that NumPy is a Python library that supports large matrices and mathematical functions on these matrices, so we'll be using that a bit. Pandas, another library, allows us to do data manipulation and analysis. So you may already be familiar with both NumPy and Pandas. There are whole courses devoted to them. We're just going to cover the basics. I'm trying to get us started as fast as possible doing machine learning and not kind of dwell in all the nuts and bolts parts of these libraries like NumPy and Pandas, although they are important. So it's kind of useful if you need more information to kind of learn it on your own. Next, we'll look at scikit-learn, which is a library that contains many machine learning algorithms. Not all of them, not the deep learning algorithms we'll be using later in the course, but an awful lot of the ones we'll be using. So instead of writing things from scratch on our own, we'll be using these algorithms that are in scikit-learn. For example, I mentioned KNN, k-nearest neighbors. We'll be using the scikit-learn implementation of that. One habit that's useful to develop is to both save and share your code and your notes. And you can do that to a degree in Google Colab, but we're going to be using GitHub. Now, I'm thinking a lot of you are already familiar with GitHub, but if you're not, here's a short summary. So Git by itself, separate from GitHub, is a version control system. And as that name suggests, it manages versions of some document or some code block. So you can keep different versions of code. So this is really useful if you're working on some code, some gnarly code, and you kind of go down the wrong path and you've made changes that you would really like to undo. So you've worked kind of in the evening, and you realize, oh, I shouldn't have deleted what I deleted and replaced it with this stuff. With a version control system, it'll enable you to do that. You can go back to the previous save and start from there. So it's an incredibly useful thing to do. It's really handy when you make horrendous mistakes and you'd like to go back to a previous version. So the way you do this is you create a repository for a project that you're working on. So you're working on this project by yourself, in a small team, or a whole company-wide effort, like if you're at a startup. And this repository will contain all the code, all the documentation, and as I mentioned, all the versions of those, the code and documentation. Now, GitHub is a cloud-based hosting service for hosting and managing these Git repositories. So it's slightly different. They're not interchangeable terms. Git is that version control system. GitHub is a service that enables you to kind of have these repositories in the cloud. We'll see more example, or we'll see an example of this shortly. So the website we're on, inquirium.com, is hosted for free at GitHub. So GitHub is a widely useful group of skills to have. And I should mention, when I talk about the word skill, that everyone who comes to this video has different sets of skills. Some people know GitHub really well, but they're kind of not so great on NumPy and Pandas, those libraries. And other people are coming to this with a good knowledge of NumPy and Pandas, but with little knowledge or no knowledge of GitHub. So if I made the assumption that nobody knows this stuff and proceed to explain everything, I would bore some group of you. So if you know GitHub really well, and if I present lecture after lecture of how to get started on GitHub, I'd bore you. And on the other hand, if I just skip this stuff and assume you know it, then I'm going to lose a good hunk of the people. So I'm kind of pursuing a middle way. I'm covering stuff in kind of a brief way and thinking that, if you know it, it's a good review. And if you don't know it, it's a way of getting started. And you might need other resources to complete your knowledge and skill set on those topics. So that's where I'm heading. So in the next video, what we're going to do is actually create a Git repository, and I just want to talk about that a bit. So that was it for this intro. See you in the Git discussion. Thanks. Bye.